So, chapter 8 is kind of a lot of information on all kinds of different ways in which you can add things to a double bond. And these are going to be electrophilic additions. I wanted to do kind of a short summary of all of these different reactions and some kind of compare and some contrast. So, how I have this, and this is on our Moodle page. On the left column here, I have what do you want to add, and then I have some different methods highlighting whether or not they're going to go, for example, Markovnikov or anti-Markovnikov, syn or anti. And those are going to be kind of all the different variations. So in our first case, if you have a double bond and you want to just purely reduce it down to just fully saturated, so add just hydrogens, you can add 2 hydrogens by using a metal catalyst. This would be something like a palladium or a platinum or a nickel with hydrogen gas. And that will be a syn addition of 2 hydrogens onto a double bond. Next, we talked about ways to add HBr, so a hydrogen and a bromine. Both of these are going to use hydrobromic acid like HBr. The key difference is if you use normal HBr, they're going to be a Markovnikov addition, so the bromine is going to go on our more substituted side. If you add a peroxide, peroxides are going to be big hints that we're going to do anti-Markovnikov. So if I do HBr and peroxide, instead we actually generate some radical species, and you're actually going to add your bromine first. And because of that, you're going to do it on the less substituted side because you want your radical on your more substituted side. So 2 different ways which you're going to HBr. If you want it on the more substituted side, just HBr. If you want it on the less substituted side, add a little bit of peroxide. We talked about all kinds of different examples of how to add an alcohol. So if you wanted to add an H and an alcohol to your double bond, the easiest is just simply using acid. A little bit of acid in an aqueous condition will add an alcohol following a Markovnikov, so that alcohol is going to go on our more substituted side. One issue with that is sometimes you can get some rearrangement. So if you wanted to make sure that you can't rearrange at all, you can do your alkoxy mercuration demercuration reaction, which is going to be one that's going to use either an alcohol or water. And if you use water, it's going to add an OH. If you use an alcohol, it's going to add an OR group. This is also going to be our Markovnikov, so you're going to generate the same product. However, it can't undergo any rearrangement. So if you have a structure that is susceptible to either doing a hydride shift or a methyl shift or resonance, and you don't want that to occur, you can use a slightly more obnoxious mercury-like complex. If you wanted to add your alcohol on the less substituted side, you can do an anti-Markovnikov with a boron complex. So this is going to be a reaction that uses a boron and then a peroxide. And again, you see that peroxide is going to be hint you're going anti-Markovnikov. And those are going to be their 3 different ways in which you can add some alcohols. Next, there are going to be some ways in which you can add different groups rather than just an H and something. The first is going to be adding 2 of your halogens. So if you wanted to add Br and Br, you can simply use Br2 in an aprotic solvent, and you want it aprotic because you don't want to do the second reaction. The opening is going to follow a kind of SN2 backside attack focus, or the opening of your bromonium ion that forms. So for that, you're going to get an anti or opposite addition. So you'll have one as a wedge, one as a dash. If you use a protic solvent, that protic solvent is going to block your Br minus from doing the attack on your bromonium. And therefore, you could have something like water open it instead. So under protic conditions, you can actually form a halohydrin, which is going to be a Br and an OH. And this is going to follow kind of a Markovnikov addition where your OH is going to go to your more substituted side and your Br is going to go to your less substituted side. Once you have a halohydrin, if you expose that to a base, you can form an epoxide. And epoxides are going to be, we're going to jump down to epoxides. There will be 2 different ways in which you can make epoxides. The first is going to be using a base with your halohydrin. Or you could also use a peroxy acid. MCPBA is a good example. Both of those are going to form the exact same peroxide, and that's going to be a syn addition. If you're trying to add 2 alcohols, like your OHs, there's going to be a variety of ways. The first is going to be if you have an epoxide, you can expose it to acidic conditions. And that's going to open up the same as like a bromonium would, with a backside attack, which is going to be an anti-addition. So your two OHs are going to be on the opposite sides. There are also ways which you can do syn addition. There is a costly but really high yielding osmium, or a cheap but very messy permanganate. Both of those will give the same stereochemistry. So you see your OH is wedge-wedge, and that's going to be a syn addition. You do need to be a little bit careful in that last one, the KMNO4, because if you do it under warm conditions, then you can actually start breaking bonds, like your ozonolysis. And this right here is attempting to be a kind of summary sheet of all of the different reactions that we've seen and some of the kind of nuances for them. Towards the end of the notes, I do also have a table for all the different reaction types and thinking about things of their rearrangement, their regioselectivity, and their stereo selectivity, talking about Markovnikov, anti-Markovnikov, syn and anti, as well as rearrangements. And that's another kind of summary. That's good, a non-pictorial form of kind of like what I just showed. So either of those hopefully should help you out. Now, there's going to be two main types of questions that we're going to see associated with these. The very first one is going to be like a pinwheel, and you'll see one on your homework, and we'll actually do this exact pinwheel in class. I call these pinwheels where you have a single starting material, and then you just say, what are all the different things I can do to it? So here there are 8 different reaction conditions that we're going to expose to that methyl cyclopentene, ENE, because we have a double bond. And we're going to explore all the different products. The other one is going to be a little bit more on a retrosynthetic kind of approach, where we're kind of building up complexity from a kind of a simple molecule to a more complex molecule. And we're going to have a full video and kind of discussion on that in our kind of next set of videos. So tons of different reactions that are going to give you tons of different products. And here's kind of like another kind of full view of all those different types of reactions. You don't need to blindly memorize a lot of these. A lot of these you can kind of just see some kind of themes. You can also use your notes to kind of like help guide you through the homework and stuff. So hopefully this isn't like too overwhelming. Chapter 8 is just all the reactions. So this is kind of like the best attempt at how we try to cover it. So let's go and end there, and then in our next set of videos, we'll start talking about how we can kind of combine these reactions with stuff that we see in chapter 4 and 6 and 7 to really kind of build up some new and kind of cool molecules.